Hey calculus students, this video is on finding absolute extrema. So there's not a ton new in this video. We're kind of like layering in a little bit more on top of the first derivative test. But basically right now, using the first derivative test, in a given an equation of a function, you can identify critical points and figure out where local maxes and mins occurs or relative maxes and mins occur. But we aren't really sure, like some of those maxes and mins might be absolute, so the absolute highest place or the absolute lowest place, and some of them might just be local. So what we're going to do in these notes is kind of address how can we decide if it's an absolute or a relative max or min. And the first thing we're going to do is a little bit of a graphing activity where we kind of visualize maxes and mins. So we're going to kind of visualizing max, mins, and we're going to think about a closed interval because it's a lot easier for us to think about absolute maxes and mins on a closed interval. And we'll say like from A to B, where A and B are x values. So we're going to kind of do a graph sketching activity, and I'm going to do one as an example, and then I'm going to have you pause it and try out some others. But we're going to sketch a graph that meets specific requirements. So sketch a graph where ... Okay, so the first one we're going to do is where if we have we're still thinking about a closed interval from A to B. So we have an absolute max at x equals A at the first endpoint and an absolute min at x equals B, the other endpoint. So if I'm trying to sketch this graph, I can kind of sketch a little quick coordinate plane, label a point A and a point B along the x-axis. And so I'm telling you I want an absolute highest point at x equals A. So I could kind of plot some point up here. That's going to be my highest point, and then maybe draw some curve where like maybe there's a local min, a local max, but neither of them are higher than the endpoint. And down here, this is the absolute lowest point. Right? So now when I kind of think about labeling things, this is my absolute max. This would be my absolute min. Now, also appearing here is going to be a relative max. I'm going to call it a REL, relative max. And then somewhere over here, I don't know if I labeled that quite right, is a relative min. Okay, sorry about if it was blurry, but I just refocused it. Hopefully that helps. Okay, so these requirements are met by this picture. I'm going to go through and write out a couple more, and I'd like you guys to pause the video and see if you can sketch a graph. Then I'll kind of go through and show you what I think the graph should look like. So let's say an absolute min at x equals A and an absolute max in the open interval from A to B. So that means the absolute max doesn't occur at either endpoint. Okay. Next one, I put B again. C, absolute max at x equals B and absolute min in the open interval from A to B, so not on an endpoint. Next one is an absolute max and absolute min in A to B on the open interval. So that means for this one, you want your absolute max and min to neither of them to be at either endpoint of a closed interval. Okay. So the last one I want you guys to think about, I'm going to leave some space and then write E, is no absolute max or min on the whole interval from A to B. Can you draw that graph? Okay. So pause this video and see about sketching these graphs, and then you can press play once you've kind of given it a shot, and I'll run through what I think these graphs could look like. Okay, so I'm going to start going through them. So for this one, I'm going to kind of start each one the same. So I'm going to just run through and sketch some graphs or set up my coordinate plane so I can move through this kind of quickly. Okay, so for the first one, B, an absolute min at x equals A and a max somewhere in the interval, the idea would be this needs to be an absolute low point, and then I need to kind of like curve up, but then come back down to get to my point B. So here's my absolute min. Here's my absolute max. And then I also have this point, this endpoint is going to be a relative min, right? And when we were looking at trig functions in class, we already kind of saw that we could have a min or a max at an endpoint when we kind of were like looking at the interval from like 0 to 2 pi or something like this. Okay, so the next one, an absolute max at x equals b and a min somewhere in the interval. So what that might look like is, so I kind of have to start, I have to get lower than this endpoint. I have to go higher at the end. So this would be my absolute max at b. And then there's an absolute min somewhere in the interval. And then we can see like what's happening at that endpoint. It's also, it's going to be a maximum, but it's going to be a relative maximum. Okay, absolute max and min in the interval. So that means like my endpoints are not the most extreme values. So maybe that looks something like that, where there's an absolute max, an absolute min, and at the endpoints are relative maxes and mins. So this would be a relative min, this would be a relative max. And it's really just a visualization thing. Like if we're going to be increasing towards a right endpoint, this will obviously be a highest point relative to the points around it. If we're increasing away from a left endpoint, that ends up being a min. So it's kind of like, it depends on which side we're looking at, what's going to be going on at the endpoints. And you just have to kind of think for a minute and visualize. Now the last one says no absolute max or min on the closed interval from A to B. I'm not sure if I'll be interested to hear from you what you came up with here, but this ends up not being possible. Like if we have a closed interval, it ends up being that we will always have an absolute max or min on that interval, no matter what. Even if I just drew like a straight line, something like that, then I would say that the absolute max and the absolute min are the exact same value, whatever value of y this is, and they occur at every single x value. So like a max or min could occur at more than one x value. So this is still, that doesn't work. So it's not possible for this to occur. And this kind of leads us to the kind of big idea here, which is going to be, it actually is a theorem in calculus called the extreme value theorem. And what the extreme value theorem says, it says if f is continuous, if we have a function that's continuous. Oh, and I meant to say above that we really, for all those sketches, you needed to have drawn continuous graphs. For something like this, it is possible if you'd make it discontinuous, but we don't. That's not what we wanted to do. Okay. So it says if f is continuous on a closed interval, that part of closed interval is important. So I'll say like from A to B, then f must have an absolute max and absolute min on that interval. Okay, now this is only true on closed intervals. We can see what happens on an open interval. So on an open interval, just to draw like a quick sketch, we could have, like, first of all, it could be like negative infinity to infinity, something like that, in which case, like, there is no absolute maximum here. There's a min, but no absolute max. And then you could also have like between 2 points, but on a open interval, so the endpoints are open, And we'll talk more about this in class, but what's going on here is like there is no absolute min, because I can always find like a lower value that's close, that's like I can get closer and closer and closer to this endpoint without actually arriving there, since it's not on the interval. So I'll always be able to find like a lower value or a higher value. So there is not one extreme max or min. No absolute max or min. Okay, so the bottom line here is that if we have a closed interval, we should be able to find out where the absolute max and min are, as opposed to just knowing, oh, this will, like if it's a relative or local max or min. So let's look at an example of how we can apply our understanding here. So my example is going to be to say find all maximums and minimums, and to identify if they are absolute or relative. Okay, so the function we're going to do is, we'll start with a polynomial. F of x equals 3x to the fourth minus 4x to the third. They say on a closed interval from -1 to 2. Okay, so the first part of this process is going to feel really similar to what we've been doing. I'm going to do the first derivative test, okay? Just like we've been doing it. So we'll say as normal. So I'm going to take the derivative. I get 12x to the third minus 12x squared. I'm going to set it equal to 0 and factor out 12x squared. I'm left with an x minus 1. Set both of those factors equal to 0, so I get x equals 0 or x equals 1. Now, I have my critical points. One key thing is when I go to make my number line, I want to include my endpoints on my number line. So I want to start at -1, end at 2. And once you do that, sometimes your critical points won't both fall on the interval, in which case you're just exclude one of your critical points if it's not actually on the interval. But in this case, they both are, so we're good. So now I need to check what's going on in between. So if between -1 and 0, if I plug in like -0.5, this is positive, and -0.5 here, this would be negative. So positive times negative will be negative. It's decreasing. Between 0, if I plug in positive 0.5 for this interval, I do positive 0.5 here, -1 is still negative, right? So this would be a negative again. And then between 1 and 2, if I plug in like 1.5, this is still positive, and now this is also positive. Okay, so we've done the first derivative test, and we can kind of see what's going on. So I see like there is no max or min at 0, but at 1, I'm going to have some sort of minimum. And then I can also consider the endpoint. Since I'm decreasing away from the left endpoint, I know this must be a max. Since I'm increasing towards the right endpoint, I know this must be also a max. So now I kind of have like these three kind of contenders for being absolute extrema. Now, in order to actually see which one is the absolute highest point, I actually need to go back and plug these x values into the original function and see which one gives us the biggest y value. That means it's the absolute extrema. Which one gives us the smallest y value? So we'll say plug in x values to, now this is important, we care about where is f of x at its highest point. So we're not plugging into the derivative, we're plugging into the original function. So plug into f of x to identify absolute versus relative extrema. So I'll typically make like a quick table of values with x and f of x, and I'll put in the values of x we care about. I don't need to check 0 because I know there's not a max or a min there, so I'm just need to check -1, 1, and 2. So at -1, if I plug -1 into f of x, the original function, I'm going to get +1 times 3, so 3. And then this will be a -1, so 3 plus 4, so it gives me 7. When I plug in +1, I get 3 minus 4, I get -1. When I plug in 2, gotta do some quick math in your head, but this ends up being 16. So what can we deduce from this? Well, we knew that the maxes were at -1 and 2. So if I compare what's going on at -1 and 2, 7 versus 16, which one will be the absolute one? It'll be the bigger one, right? So now I know this is the absolute max, and this must be the relative max. And then for the -1, it's the only minimum, right? There is no other minimum, so it must be the absolute minimum. If there's no other one, that's the absolute one. Okay, and I just want to give you a little bit of kind of formal, how are we going to kind of share out our answer? So the idea is like the y value is the max or min, and it occurs at a specific x value. So I could say like absolute max is y equals 16, and it occurs at x equals 2. Sometimes your max could occur at more than one value, in which case you could say like at x equals 2 and another x value. So absolute min is y equals -1 at x equals 1. Then we can also say that we have a relative max is y equals y equals 7 at x equals -1. Okay, and that would be like my answer to the question. All right, so now it's time to give you guys some U-tries. Gonna give you 2 U-tries. We'll say U-try 1 and U-try 2. So the first one is going to be a polynomial. So 2x to the third minus 6x, and I'm going to give you an interval to look on, -1 to 5. And just so that, since we did all that algebra work on Thursday, let's give you a non-polynomial function to think about. So 1 minus the quantity x minus 1 to the 2/3 on the interval from -1 to 2. And so your goal is to kind of follow the same instructions as above, which were, if I slide down, or slide up, find all the maximums and minimums and identify absolute versus relative values. Okay, so that's what you're doing for both of these problems. We'll be discussing it in class. Have a great weekend.